Welcome! This is part 3 of the video series describing Amazon EC2. In part 3, we discuss tagging, security groups, key pairs, the AWS CLI, and essential information about running instances and instance lifecycle. A tag is a label that you assign to an AWS resource, such as an EC2 instance. Each tag consists of a key and an optional value, both of which you define. Tags enable you to categorize AWS resources in different ways. For example, you might tag instances by purpose, owner, or environment. Tagging is how you can attach metadata to an EC2 instance. For example, a commonly used tag for EC2 instances is a tag key called name and a tag value that describes the instance, such as web server 1. The name tag is exposed by default in the Amazon EC2 console instances page. It's best practice to develop tagging strategies. Using a consistent set of tag keys makes it easier for you to manage your resources. A security group acts as a virtual firewall that controls network traffic for one or more instances. When you launch an instance, you can specify one or more security groups. Otherwise, the default security group is used. You can add rules to each security group. Rules allow traffic to or from its associated instance. When traffic attempts to reach an instance, all the rules from all the security groups that are associated with the instance are evaluated. When you define a rule, you can specify the allowable source of the network communication for inbound rules or destination for outbound rules. The source can be an IP address, an IP address range, another security group, a VPC endpoint, or anywhere, which means that all sources will be allowed. By default, a security group includes an outbound rule that allows all outbound traffic. The inbound traffic rule shown here allows secure shell or SSH traffic over TCP port 22 if the source of the request is my IP. The my IP address is calculated by determining what IP address you are currently connected to the AWS cloud from when you define the rule. The last important choice to make when launching an EC2 instance through the wizard is to specify a key pair. A key pair consists of a public key and a private key. It enables secure connections to an EC2 instance. When creating an EC2 instance, you can choose an existing key pair, proceed without a key pair, or create a new key pair. You must make this decision before you can choose Launch Instances and create the EC2 instance. If you create a new key pair, download it and save it in a safe location. The only opportunity you have to download and save the new private key is at the time of creation. To connect to a Windows instance, you use the private key to obtain the administrator password and then log into the EC2 instance's Windows desktop by using Remote Desktop Protocol or RDP. To establish an SSH connection from a Windows machine to an Amazon EC2 instance, you can use a tool such as PuTTY, which will require the same private key. To log into a Linux instance, for example by using SSH, you must provide the private key when you establish the connection. After you choose Launch Instances and then choose View Instances, you will see a screen that looks like the example shown here. Many of the settings that you specified during launch are visible in the description panel. Information about the available instance includes IP address and DNS address information, the instance type, the unique instance ID that was assigned to the instance, the AMI ID of the AMI that you used to launch the instance, the VPC ID, the subnet ID, and more. Many of these details provide hyperlinks that you can choose to learn more information about the resources that are relevant to the EC2 instance you launched. The Launch Instance Wizard is not the only way to launch an instance. You can also launch EC2 instances programmatically, either by using the AWS command line interface or through one of the AWS SDKs. In this example AWS CLI command, you can see a single command that specifies the minimal information that is needed to launch an instance. Let's review the details of the command. AWS invokes the AWS command line utility. EC2 invokes the EC2 service. Run-instances is the subcommand that will be run. The rest of the command specifies several parameters, including image ID, which is the AMI ID. All AMIs have a unique AMI ID. Count, you can launch more than one instance with a single command. Instance type, specify the instance type to create, for example, a C3 large instance. Key name, in this example, we assume that my key pair already exists. Security groups, we also assume that my security group already exists. Region, AMIs exist in an AWS region, so you must specify the region where the AWS CLI will find the AMI and other referenced resources. And this is the region that the instance will be launched into. The command should successfully create an EC2 instance if the command is properly formatted, the resources that the command needs already exist, you have permissions to run the command, and you have sufficient capacity in the AWS account. If the command is successful, the API responds to the command with the instance ID and other relevant data for your application to use in subsequent API requests. As you can see, the AWS CLI is a powerful tool for programmatic access to AWS. Now that you understand how an instance is launched, let's consider the different states that an instance can be brought in throughout its lifecycle. The arrows in this diagram show actions that can be taken, and the boxes show the state the instance will enter after the action. After it's launched from an AMI, an instance will be in a pending state before it reaches a running state. An instance will also initially enter a pending state if it was stopped and then restarted. A running instance is fully booted and ready. Running instances can be rebooted. A rebooted instance stays on the same physical host, maintains the same public DNS name and public IP address, and if it has instant store volumes, it retains the data on those volumes. Running instances can also be terminated. If they are, they will enter a temporary shutting down state before they are terminated. A terminated instance remains visible in the Amazon EC2 console for a while before the virtual machine is deleted. However, you can't connect to or recover a terminated instance. Finally, instances that are backed by Amazon EBS can be stopped. They enter the stopping state before they attain the fully stopped state. A stopped instance will not incur the same cost as a running instance. Starting a stopped instance puts it back into the pending state, which moves the instance to a new host machine. A public IP address is an IPv4 address reachable from the internet. Each instance that receives a public IP address is also given an external DNS host name. Any dynamically assigned public IP address assigned to an EC2 instance will be released when the instance is stopped or terminated. When the instance is started again, it will receive a new public IP address. When a public IP address is disassociated from your instance, it is released back into the public IPv4 address pool, and you will not be able to specify that you want to reuse it. If you require a persistent public IP address, consider associating an elastic IP address with the instance. To do this, first allocate a new elastic IP address in the region where the instance exists. Then, you can associate the elastic IP address with the instance. By default, all AWS accounts are limited to 5 elastic IP addresses per region because public internet addresses are scarce. However, this is a soft limit, and you can request a limit increase. Instance metadata is data about your instance. You can view it while you're connected to the instance. In a browser, go to 169.254.169.254/latest/meta-data. The data can also be read programmatically, such as from a terminal window using the curl utility. The IP address 169.254.169.254 is a link local address, and it is valid only from the instance. Instance metadata provides much of the same information about the running instance that you can find in the AWS Management Console. For example, you can discover the public IP address, private IP address, public host name, instance ID, security groups, region, availability zone, and more. Any user data specified at instance launch can also be accessed at 169.254.169.254/latest/user-data. EC2 instance metadata can be used to configure or manage a running instance. For example, you can author a configuration script that accesses the metadata information and uses it to configure applications or OS settings. Finally, you can monitor your instances using Amazon CloudWatch, which collects and processes raw data from Amazon EC2 into near real-time metrics. These statistics are maintained for 15 months, so you can access historical information and gain a better perspective on how your web application or service is performing. By default, Amazon EC2 provides basic monitoring, which sends metric data to CloudWatch every 5 minutes. To send metric data for your instance to CloudWatch every minute, you can enable detailed monitoring. In the screenshot here, you can see that the Amazon EC2 console displays a series of graphs based on the raw data from Amazon CloudWatch. Thanks for watching. This concludes the 3-part video series on Amazon EC2. See you.
Hello everyone. In this demo video, I will show you the basic process of how to launch an Amazon EC2 instance on Management Console. First, please check if the region in the upper right corner of the Management Console is the region where you plan to launch the EC2 instance, and change it if necessary. Then, type EC2 in Management Console search window and select EC2 from the candidate list, or click Services and Compute, then select EC2. In this process, if you have recently accessed the EC2 instance page, it will be displayed in Recently Visited pane, so you can select it from here. OK. This page is the main page for EC2 instance and the related features. You can show this page at any time by choosing EC2 Dashboard in the navigation pane on the left-hand side. If we want to launch an EC2 instance, click Launch Instance in the Launch Instance section, or go to Instance page, then click Launch Instances button. Using this page, you can set up EC2 instance you want to launch. This first setting is the name of the instance. Give this instance a display name in the Name and Tag section. This is internally registered as a tag named Name. In this demo, I will name it Academy Demo. In the next section, Application and OS Images, you can choose the Amazon Machine Image or AMI to use when launching. Ready-to-use AMIs are listed under the Quick Start tab. At this time, I choose Amazon Linux on the far left, and from the Amazon Machine Image, AMI below it. Here, I'm going to choose Amazon Linux 2 AMI as a demo. This choice determines the OS in your launching EC2 instance. For your information, you can create your own AMI too. In that case, when you choose Browse More AMIs here on the right hand side, you can see My AMIs tab here, and you can choose an AMI that you have already created. Additionally, if you use an AMI sold in the marketplace, you can choose Necessary AMI under other tabs here. OK, move to the next. The third configuration is instance type. Now let's determine the instance specs here. Select the instance type from the drop-down list. At this time, I will select T2 Micro, which is default as a demo. The fourth setting is key pair. This is a setting to set the key to be used when logging into the OS of the EC2 instance after launching. When the EC2 instance is running, you can access the OS using a key set here. So it is usually set it up. If you have already created a key pair, please make sure you have access to it, then select it. Here, select Academy Demo Key and Virginia that has been created. If you haven't created a key pair yet, or if you want to create a new one here, click the Create a New Key Pair link to create one. Then click the Update icon after created. Note that if you don't need to log into the OS, you can choose not to set it up, but this is not recommended. The next configuration is the network, where this instance will be launched. First, you can click the Edit button to configure network settings. Then select a VPC and the subnet within that VPC. Choosing a subnet automatically determines which availability zone the EC2 instance is placed in. I will try to log in directly later in this demo, so I will launch the instance into a public subnet that can be reached from the internet. Also, make a public IP address available. Next is a firewall, that is security groups. You can create a new one here, or if you have already created a security group, you can choose it from select existing security groups. If you are creating a new security group, set a name and description for the security group below, and set specific inbound rules. Here, Academy Demo SG has been set up, so I choose it. As I mentioned before, I will try connecting via SSH and connecting via Management Console later, and my selected Academy Demo SG allows SSH and HTTPS. The sixth configuration item is storage. Here, you can set up one or more EBS. An SSD type EBS volume is required for the root volume. For this demo, I will leave it as a default. Further, when you expand advanced details here, you can configure detail settings. In this demo, I will just show you some of them. First, check this checkbox of Request Spot Instances if we want to launch this instance as a spot instance. Additionally, by clicking the Customize link, so you can set some conditions like spot price, etc. by yourself. In this demo, this instance will be set up as on-demand instance, so I remove this check. IAM instance profile is where you set up your IAM role. You can also create a new role here if needed. Instance auto recovery is a choice to enable the auto recovery function, which launches an instance with exactly same settings when an internal failure occurs and the instance stops. The stop hibernate behavior is the activation of the hibernate option, which also archives memory when the instance is stopped. Termination protection and stop protection are settings that prevent these operations from being accidentally performed. Tenancy is a setting required when using dedicated instances or dedicated host option. And user data text box at the bottom is a place to write a script that automatically runs only the first time this instance is started. By writing a shell script for Linux and a PowerShell script for Windows, it will only run once at the beginning. However, it is important that the script does not cause errors, since it will simply start up even if an error occurs. Also, it's a good idea to check later to see if any errors have occurred. Finally, enter how many instances you want to launch with these configurations, and click Launch Instance button. You can see Success banner here. Then click View All Instances button here. After you wait for a while, the instance you just launched will be shown in this list. The status changes from pending to running, and status check will be complete. Now, after waiting for a while, the EC2 instance was successfully launched. Congratulations! Let's connect to this EC2 instance. As I mentioned before in this video, I try to connect with SSH using a key pair since I have launched a Linux instance. Then after that, I also try to connect using the EC2 Instance Connect tool on the management console. First, let's log in with SSH. Prepare the necessary tools in advance to connect via SSH. Here, I use PuTTY. Copy and paste the IP address or domain name of the EC2 instance. You can get it from this EC2 instance details in the management console. In order to get instance detail information, you can click Instance ID link. Then you can see the public IP address or public domain names here, whichever you want to use. At this moment, I will copy this IP address, then paste it. Next, set a key prepared in the key pair on the connection settings screen, which is connection, then SSH. Open the SSH. You can see auth here. Then you can see the browse button here. You can choose key pair key. Finally, set a session retention time so you don't lose connectivity as soon as you connect, which locates under connection here. You can put the number of seconds. I'll set it to 60 seconds here. Now, I'm ready to go. Let's try connecting. Click the Open button here. When you access the EC2 instance first time, you are asked about it is okay to access this EC2 instance. So you can just click Accept button. You will be asked for username. In the case of Amazon Linux, EC2-user is prepared, so use this username here. Congratulations! Now you can connect to the Linux OS as expected. Close this window when you disconnect. Okay, now let's try to use the connection function in the management console. Go back to the management console, choose the EC2 instance, and click Connect button at the top. This page shows some options to connect EC2 instance. At this moment, I try to use EC2 Instance Connect. You can see the IP address and the username here, so you can just click Connect at this moment. When you log into the OS using this functionality, you have already logged in as EC2 user. Also, you can see the home directory. If you can use this way, it is easy to access the EC2 instance without any specific application. Well, when disconnecting, you can just close this window. Okay, now finally, let's delete the instance you just launched. Select the instance you want to delete, then go to the Instance State drop-down. Choose Terminate Instance. You are confirmed if it is okay to delete it, so just click Terminate. Now the instance state is changed to the shutting down, then terminate it after a while. Now this instance has been terminated. It will appear on this list for a while, but after a while it will also disappear from this table. This concludes my demo of launching, connecting, and deleting an EC2 instance. Thank you for watching.
Welcome. This video will discuss Amazon EC2 cost optimization. Amazon offers different pricing models to choose from when you want to run EC2 instances. On-demand instances are eligible for the AWS free tier. They have the lowest upfront cost and the most flexibility. There are no upfront commitments or long-term contracts. Dedicated hosts are physical servers where instance capacity that is dedicated for your use. They enable you to use your existing software licenses, such as Microsoft SQL Server, and dedicated instances are instances that you run in a virtual private cloud on hardware that is dedicated to a single customer. Reserved instance enables you to reserve computing capacity for 1-year or 3-year terms with low hourly running costs. The discounted usage price is fixed for as long as you own the reserved instance. Scheduled reserved instances enable you to purchase capacity reservations that recur on a daily, weekly, or monthly basis with a specified duration for a 1-year term. Spot instances enable you to bid on unused EC2 instance capacity, which can lower your costs. The hourly price for a spot instance fluctuates depending on the supply and demand. Your instance runs whenever the bid exceeds the current market price. It is important to note that per-second billing is available, but only for on-demand instances, reserved instances, and spot instances that run on Amazon Linux or Ubuntu. Each Amazon EC2 pricing model provides a different set of benefits. On-demand instances offer low cost and flexibility with no long-term contract. Spot instances provide large scale at significantly discounted price. Reserved instances are a good choice for predictable or steady state compute needs. Dedicated hosts are a good choice when you have licensing restrictions or need to meet compliance or regulatory requirements. Let's take a closer look at the pricing options and some of the more common use cases. On-demand instance pricing works well for spiky workloads, or if you need to run a test or maybe an application for a short amount of time, for example, during a development or testing period. If your workloads are unpredictable, short-term, or spiky, on-demand instances are a good choice. Spot instances are a good choice if your application can tolerate interruption, and possibly have the spot instance be terminated with a 2-minute warning. By default, when interrupted instances are terminated, you can configure them to stop or hibernate instead. Common use cases for spot instances include fault-tolerant applications such as web servers, API backends, and big data processing. Reserved instances are a good choice when you have a long-term workload with predictable usage patterns, such as servers that you know will want to run for over a consistent amount of months or years. Dedicated hosts are a good choice when you have existing per-socket, per-core, or per-VM licensing, and you must address specific corporate, compliance, and regulatory requirements. To optimize cost, you should consider the 4 pillars of cost optimization. First, you must right-size. That is, choose the right balance of instance types. It's important to notice that when servers can be sized down or turned off and still meet your performance requirements, that this affects cost. Second is increase elasticity. Design your deployments to reduce the amount of server capacity that sits idle by implementing deployments that are elastic, such as deployments that use automatic scaling to handle peak loads. Third, choose optimal pricing. Analyze your current usage patterns so that you can run EC2 instances with the right mix of pricing options. And finally, optimize your storage choices. Reduce unused storage overhead and choose less expensive storage options if they can still meet your storage performance requirements. Let's look at the right sizing in more detail. AWS offers more than 60 instance types and sizes. The broad selection enables customers to choose the instance that best fits their workload. It can be difficult to know where to start and what instance choice will be best for your application. Review your deployed resources and look for opportunities to downsize when possible. Use Amazon CloudWatch metrics to review CPU, RAM, storage, and network utilization and identify the instances that could be downsized. Select the most cost-effective instance available that still meets your performance requirements, and if your usage pattern will be consistent, purchase reserved instances. Let's take a closer look at increasing elasticity in more detail. Elasticity is one of the central principles of the cloud, but customers often go through a learning process to operationalize elasticity to drive cost savings. One form of elasticity is the stop or hibernate Amazon EBS-backed EC2 instances when they are not in use.